Here's our tab for a parallelogram. The reason that a parallelogram has a generic name, you can have different kinds of shapes that are also called parallelograms, and all that means is that a parallelogram is going to have a line at the top, a line at the bottom that are congruent. So we can use our little marks like we did before to show that these two lines would be congruent. But a parallelogram also has two more sides. They may or may not be the same length, but in this case they are parallel, and they may not be the same size as the top lines. So we could use the same double marks on these sides to show that they are congruent. So let's get our formula. You're going to need to look at your formula chart. And for a parallelogram, it's just like a rectangle. Base times height. Now the only difference between this parallelogram and a rectangle is I need a right angle, and on a rectangle they're already there with right angles. But on this one, I'm going to have to use this imaginary line to identify a right angle. And now that I know my right angle, I know that the height and the base will be connected to that right angle. So we'll use the measures for the base will be 4 meters. The height will be 6 meters. So let's calculate our example. The area of this parallelogram would be 4 meters times 6 meters, which gives us 24 meters squared. And just like before, we have an exponent of 2 on our unit of measure because we multiplied 2 dimensions or 2 measures to get this 24. 1, 2 measures. I'm going to show you one more thing just so you understand why a parallelogram is calculated with the same formula as a rectangle. So if we had a rectangle with these same dimensions of a height 6 meters and a base of 4 meters, we could have taken an imaginary line and cut this triangle and moved it. Remember, this is imaginary. You have to do it mentally. And if we moved that over, now it looks like a rectangle. This rectangle would be also 24 meters squared. So to cover our parallelogram, it would take 24 meters squared.